The basic idea is to draw something in the browser and animate it. The first thing that comes to my mind is moving particles, and there it is. You can see them flying across a viewport. To add more sense to this chaotic movement, collisions with borders are calculated, so particles bounce off the borders. To draw lines, shapes, images, etc. on the fly, there is HTML canvas element. Canvas API allows us to do all this in real time using JavaScript. In the bottom section, which is the footer, frames per second FPS are displayed. The next line displays the current canvas size in pixels, and last is the control slider, which allows us to change the number of particles. We start with a simple HTML template. The body element. Div element with ID equal to the wrapper is the top-level parent element, with two children elements inside, main and footer. They are block-level semantic elements, and you can use div or other block-level elements instead. It's a matter of personal preference. Inside the main is just one child, the canvas element. All actions will happen here on canvas. Next comes the footer element with three children, two HT elements to display some info, and the labeled input element with type equal to range. It's a slider to change the number of particles. And that's it for the body HTML element. Now to the styling. All is done in the style element. A universal selector selects all elements. Margin 0, padding 0, box size in border box. Hashtag wrapper selects the element with ID equal to wrapper. That's parent element occupies the whole viewport, 100% viewport width and 100% viewport height. CSS display property set to grid. Grid template rows. One fraction 100 pixels organize the grid in two rows. The bottom row has 100 pixel height. It will be the footer, and the remaining height will be the main element height. Overflow hidden means the content outside of the element will be clipped. Main element selector. Grid area 1/1/2/2/ selects the top row of the two present rows. If you don't know this syntax, just Google something like CSS grid or CSS grid area. Position relative, background color white. The footer element selector. Grid area CSS shorthand property selects the bottom row. Position relative, background color gray, or whatever you like. Padding 10 pixels, 40 pixels. The last is the canvas element selector. Position absolute, width 100%, means it takes all its parent widths. The same for height. Now the most interesting part, JavaScript. With these green comments lines, global variables, events, logic, and start from here, the code is split into sections to give it some structure. Global variables. Mouse down is a flag variable, will be dynamically updated by mouse down and mouse up events. It will hold true or false respectively. Particles array is the array which holds objects, particles. It will be an array of objects. Lines from 53 to 57 do simple things, select elements and assign them to variables. Line 58 assign a two-dimensional drawing context to the cityx variable. Now to the events. There are four of them. Mouse down and mouse up events trigger the isMouseDown flag variable to true and false. Change event on input element with type equal to range, that's a slider. Display its value in labeled element and call initParticles function. And last is the resize event on Windows. Is fired when the document view, e.g. Windows, is resized. This event calls the initCanvas function. Logic section. Function initCanvas. To the variable bound in rect, assigned object DOM_rect. This object provides information about the size and position of main element. In lines 74 and 75, we assign the width and height of this object to the canvas, meaning that the canvas will be the same size as its parent main element. Take a look at the body element line 40. At the end of the init canvas event, we display canvas width and height as text inside info2 element. Function init particles with one parameter qt, its abbreviation for quantity. This function will delete all elements of the array particles in line 79. In the while loop, using a new operator and class particle, push objects constructed by class particle in the particles array. The number of particles in the array will be equal to the argument qt passed to the function at call time. Declaration of class particle. It's a template for creating particle objects. The constructor method is executed automatically when a new object is created. Each particle object will have properties initialized. Radius, a random number in a range from 2 to 9. X position will be a random position, taking into account particle's radius in such a way that the particle will not overlap canvas borders. The same thing for the y position, while x and while y will be horizontal and vertical velocities. And random color. Function update will be called in the animation loop for every frame of the animation to change particle position in that frame. As an argument, this function receives a particle object. Take a brief look at class particle. These are particle object properties to work with. First particle horizontal and vertical positions are calculated simply by adding velocities to the current positions. Next, I assign canvas width and canvas height to variables w and h, just to save some effort typing these variable names. Now we need to implement some collision detection to contain all particles within a canvas and not let them fly in open space. First if statement checks the collision with the left canvas border. Our particles have the shape of a circle, and its position is the center coordinates of this circle. Keeping this in mind, if condition p.x less or equal p.radius, check if the left canvas border slices the circle. If it does, we change the direction of the particle's horizontal component of speed to the opposite, effectively bouncing the particles from the border. In line 101, the particle positioned exactly on the border. The next three if statements apply the same logic to the rest three borders of the canvas. That's all for the update function. Function render. Here happens all particle drawings on the canvas. As the update function, it's a unary function with just one argument, particle object. All basic stuff inside. Pick up particle color, fill color, begin path, drawing a full circle shape, and fill it with particle color. Next and last is the animate function. Here goes the animation loop to make all this stuff alive. Request animation frame method tells the browser to call the animate callback function before the next repaint. The frequency of calls will match the display refresh rate. The animate function will have one parameter, its timestamp. Timestamp is a decimal number in milliseconds. Indicates the end of time of the previous frame's rendering. Frame time is the difference between the timestamp and last time. And after the frame time is calculated, last time is updated. Now we can display the frames per second info as 1 second, e.g. 100 milliseconds divided by frame time. Just to add some functionality, we check the isMouseDown flag variable. If it's false, everything on the canvas is erased. For each array method, calls update and render function for every element in the particles array. All for the logic section. When the browser runs our JavaScript, it starts here. We initialize canvas to give it size, Next, the particle array is populated with particles. The number of particles will be equal to the number which holds the slider. Unload event, immediately after the page is loaded, calls animate function for the first time, passing 0 as the initial timestamp value. Hopefully you get something useful from all these tedious explanations.